Okay, if this doesn't cause a bad network connection, nothing will. By the time we're done here, we will explore interface counters to determine issues on switch port connections. All right, it's your turn. I still remember when I got into this concept, when I first stepped into the Cisco world, and I'm like, oh man, it's not hard. There's just so much, right? So first off, budget a little extra time for this video. It's going to be a little longer because we are going to dive into the show interface output of switch port counters. And this is so key because it's going to help you understand what's happening in your network environment. And when you isolate a device, we've talked about already how to find devices based on their MAC addresses. And so you find one, you're like, okay, what's the problem here? This is where you can start looking at what is the actual data going in and out, and is there any problems with it? So now let's come back here. What's going on here, Jeremy? So I spent an inordinate amount of time. I'm going to post it to social. How to build a mostly bad Ethernet cable. And believe it or not, this is actually not one of them. This is one of my failed attempts. This cable works just fine, much to my dismay, despite hatchets and dinosaur teeth going into it. Let me give you a bigger picture. This little cable actually connects this switch up to my production network. So here's what I'm doing. Over here, I have a Synology device. It is network attached storage, which is essentially hard drives plugged into a network, right? I have a lot of these because I record a lot of video and I need a lot of storage and a lot of backups. This happens to be one of my backup devices. It connects to this black Ethernet cord, which runs along right here into this switch, right? I then connected this switch to my production network with this funky Ethernet cable right here, thinking that that would be bad. Believe it or not, it's actually not. This is a fine connection. Now, I figured out how to build a bad one, but I first off want to show you what a good network connection looks like. I'll start off by showing you this. This is my production Synology system that is about 22 gigabytes into a backup to that little white Synology box I just showed you, right? So in front of this, I'm going to open a command prompt and connect to that Las Vegas or Nevada switch, right? So I'm going to telnet to 192.168.2.2. Hit the enter key, get logged in. Move that over just a little bit. There we go. Get into privilege mode. Actually, this command will work even when you're not in privilege mode, but we'll go here just because. So I'm going to do, first off, a show interface status. Just to get us familiar, Fast Ethernet 0/1 is the one that had that funky cable connected. This guy right here, if you see, it goes through the dinosaur's mouth into Fast Ethernet 0/1. Fast Ethernet 0/2 is the one that's connected to the Synology device. Now, here's the output. I'm going to type in show interface Fast Ethernet 0/1 and hit the enter key. Ooh, all right. Grab your cup of coffee, get your notepad, and let's start talking together, okay? So here's the key pieces of this. First off, it says Fast Ethernet 0/1 is up. Line protocol is up. That is the same information that you get when you do the show IP interface brief and you're looking at the physical layer and the data link layer, same, right? So when you see up and up, just go, okay, great. That's the same output as what we saw above. So that's what that is. Okay, hardware's Fast Ethernet. Okay, great. If it was gigabit Ethernet, it'd tell you that too. The MAC address is right here. It's just saying the built-in address of this switch is this. Then we get into the maximum transmission unit. It's 1,500 bytes. That's the largest frame that it can handle. How much bandwidth this can handle maximum is 100,000 kilobits per second, or technically 100 megabits per second, right? And you can go through all of the different things here. Here's something relevant. Notice TX load and RX load. Anytime you see TX, just think T, transmit. That's what it stands for, transmit. Transmit load is 6 out of 255. What does that mean? Well, that would be Cisco being like, let's make this more difficult. Instead of being 0 to 100%, let's make it 0 to 255. Yeah. And so that's what they did. So 255 is really 100% utilized. So you can see on the transmit, it's not doing too bad. It's got plenty of room to expand. RX is receive. Okay, that one is pretty much maxed out. 249 out of 255. Because if you think about it, let's look back over here. I've got all of this data coming in. Oh, hang on. Didn't flip the slide. There we go. All of this data coming in from the production network through the dinosaurs down into Nevada. So what is that? Is that transmit? No. Because from the switch's perspective, transmit would be it sending, right? This is receiving data. So look back at those figures. RX load saying I'm receiving on fast Ethernet 0/1 a whole bunch of data. Now wait a sec. Hang on. Think this with me. If I do the show interface counters for the one going to the Synology, what would you expect to see? Think about that. Let's see. I'm going to type in show interface fast Ethernet 0/2, and look at that. Did you get it? It's flipped. I guess I should have specified a little closer. What do you expect? Of course, a lot of stuff, but the transmit, because now it's saying, okay, I'm receiving it on fast Ethernet 0/1. I'm transmitting it out fast Ethernet 0/2, so I see the true saturation right here. But receive-wise on the Synology is not that bad, right? Because it's not the one sending all the data. It's receiving all the data. Well, and you get that backwards, right? So I'm going to hit the up arrow and go back to fast Ethernet 0/1. Scroll down a little bit more, we see keep alive, blah, blah, blah. Full duplex, 100 megabits per second. Here's your media type, and I'm just going to go down here. This is where the real action happens in the output queue. You see right here, right below this output queue line. So 5-minute input rate, 5-minute output rate. So the switch automatically does an average. Just stare at that for a second. It does an average over the last 5 minutes. So keep that in mind. When you're expecting to see something happen right away, you do a big data transfer, it's averaging it over 5 minutes. So you're not going to see it suddenly spike. You got to give it some time to get up there, which I have. You can see this guy is at about 981, what is that, million? Something, bits per second. This is 981,000 kilobits per second, or about 98.1 megabits per second, right? Again, the fastest this guy can go is 100 megabits per second. This is showing it fanned out in bits per second. I feel like I'm saying a lot of words, so let me just stop for a second, right? You get that? Bits per second, kilobits per second is 1,000 bits per second. Megabits per second is 1,000 kilobits per second. So that's where all this number comes from. So this is technically 98.1 megabits per second. This is how many packets per second it's sending, right? And then now right here is where all the statistics come in. You see the number of packets input. We see how many bytes have been sent, and you can see a lot of bytes. I mean, obviously, I've got my backup going. I'm 26 gigabytes into the backup at this point. So a lot of data is coming in. And this right here, now you see the broadcast, how many broadcasts are being sent on the network. Ooh, something worth mentioning. These are all memory resident. So you reboot your switch, you're going to lose all of these. You can also type in clear counters. Here, I'll do fast Ethernet 0/2 because we can do that. And now when I look at that interface, you can see everything's reset. So the 5-minute average is still the same, but the number of packets that have been sent kind of start from 0. And it's building up quickly because we're receiving a whole bunch of stuff. Dope! I stopped to grab a cup of coffee and I lost my connection. So, coffee ready? You got yours? Let's go through the meat of this and where we can find some errors happening on the interface. We get reconnected to that switch. Log in, enable, log in, and let's do show interface fast Ethernet 0/1. And okay, so we're still transferring a ton of data. That's 98 megabits per second, 98.5 megabits per second. So let's look at these. So we've got, first off, the number of broadcasts. So broadcasts can signal something going crazy on your network. There is a symptom called a broadcast storm. It typically happens when there's a loop in the network where you end up with a couple switches that are connected on multiple links, and spanning tree protocol either isn't enabled or it doesn't work. Then what happens is a broadcast will start going around and it literally can take out your whole network. So if you're looking at your statistics and you see a whole bunch of broadcasts that are just ticking up, that could signal, hey, there's a broadcast storm going on. As it stands right now, it's kind of like, wow, it seems like a lot, but when you compare it to the number of total packets input, it's like, that's nowhere even close. Now let's hit some of these big ones. And first off, let me do this. I'm going to show you my prized possession. So I showed you a minute ago this little dinosaur munching cable. That was actually failed attempt number, I don't know, 10, 11. It literally took me about 18 different cables to get it just right. This is my magic cable. I told you I'm going to post to social media on this. This is my magic cable that causes partial connectivity. It's a mostly bad Ethernet cable where I can get connection. It still works, but it causes all kind of packet errors. I'll tell you what I did. Here's the secret formula if you want to save going to my social post. What I did was I first off messed up the color scheme, and I took each one of these has two for transmit and two for receive, right? You know that. So we've got, that's literally the minimum number of wires needed to make that connection possible. So I took the receive and I literally spliced it together with the transmit. So literally the two wires sitting next to each other are sending competing signals. Then I figured out the exact cable length, because when I had like a 5-foot cable, it wouldn't work. 4 foot, literally, like I was down to like the inches and trying to get to the point where it would get a signal. And so, well, I'm going to leave it at that. Go to the social post to find out the exact length. Just looking at it isn't going to help. You need the exact measurement in order for this to work. Okay, so back over here. What I'm going to do is, I may lose the connection as I do this. I'm going to disconnect my failed attempt at making a bad cable, because it actually turned out to be good, and plugged in my coveted successful attempt at making a bad cable. So if this goes right, we should get a new connection. There we go. So it's gonna it's gonna take a little bit. I don't know if you can see it. There's a big old wire in front. Sorry about that. Down in front. I could go on. It took so long for me to make this cable. I could go on and on about all the things that didn't work, but it's coming up right now. So right now we've got. As soon as that guy turns green from amber, it's got Spanning Tree testing the line, making sure all is well. We should get the connectivity going back again between the two Synology, but it's going to be, there we go, over a mostly good Ethernet cable, so it should struggle. Okay, so let's come back over here. I'm going to hit the up arrow. And look at that, we're already getting some. So one input error coming in. Okay, so these are going to be some of the things that happen as we have bad connectivity. Oh yeah, oh my goodness, I can tell you how exciting it is to see bad transmission. It took me so long. The funny thing is, this kind of thing happens all the time when people roll over the cable with their rolling desk chair and all that kind of stuff. I guess I'm just so excited about this because it took so long to figure out that formula to get a really mostly bad cable. So right, what's going on right here? Okay, take a look right here. When I see this, that tells me there is something very wrong going on. You're like, well, yeah, obviously. So input errors. Hang on, let me get back to my slide for a quick sec. There we go. I'm actually going to start from the bottom and work my way up. All right, there we go. So it looks like I'm going to start from the bottom and work my way up. What you're seeing on the output, it's a whole bunch of input errors. So input error pretty much means that a bad frame is received. Now, that could be because of the cyclical redundancy check. It could be because the frame is a runt. It could be because the frame is a giant. See all these other things I'm going to explain to you in just a second. So hang on, let me get back to the output here. The input errors is kind of like a generic summation of everything that's going on. So 22,230 input errors. Of those, 22,178 had a bad cyclical redundancy check. That's literally the frame, the little hash at the end of the frame didn't match right. That's because some data got scrambled or messed up somewhere in the transmission because of my really amazing bad Ethernet cable. So think of these as two different things. Input error is a summation of how many giants, how many runts, how many CRCs, total all those up, and you end up with your CRC errors, right? And any other reason that there was, or CRC input errors, right? Any other reason that the input packet had to be dropped. So when you have a frame error, that means that something in the frame is wrong, meaning the frame has a well-known format. And sometimes, for instance, there will be proprietary editions that add their own little header into the frame. They're like, oh, let's just squeeze in this sub VLAN something or another because you've got a proprietary switch. Well, if you mix that proprietary switch and say a Cisco switch, it's going to be like, I don't understand what that is. That's a bad frame from what I'm seeing because you're not following the standard frame format. So if you have those kind of messages, you're going to see frame errors. Giants, what about that? That is where you have a frame that exceeds this right here. And that name should give it away. It's a giant. It's above 1,500 bytes inside of that frame. If you have that, it's considered a giant frame. Now, there are efficiencies in like data centers and things like that, where they can enable something called jumbo frames. I don't want to. It's a lot, I know. jumbo frames is where you're intentionally allowing larger frames, because think of it like the more you can pack into a box, it's like, moving or shipping, right? The more that you can pack in a box before you send it, the more efficient you can be. Get big boxes, right? So that's the idea of jumbo frames. But you have to configure the switch to participate in that. Otherwise, it will recognize all those jumbo frames, which are frames that, you can get like 8,000, 16,000 bytes inside of a jumbo frame, depending on what you configure. But if you don't configure your switch for it, it'll say all of those are giants, right? You follow that? Runts. Those are frames that are less than 64 bytes. Usually that happens when there's a collision. When you have a collision, frame, it literally is like an explosion. It's like chunk. It's more, not so much an explosion. Think of it like, this is terrible, like a car accident, right? You're at the intersection, right? The guy starts going here, and it's like, and it kind of like takes out the front of the car. Well, that front of the car is like, and ends up flying into the switch interface, right? And the switch interface is like, whoa, what's this? It's like 32 bytes of something. It's like a chunk of something, and it's like that's below what you should even be able to send on an Ethernet cable. That's a runt. So if it's below 64 bytes, it's considered a runt. There's a whole bunch of other things, but let me mention this down below here. And I'm sifting it down. That's why I said this is overwhelming. It's a lot of stuff. I'm sifting it down to exactly what you really want to know when you're troubleshooting bad connections. This guy right here, collisions and late collisions. Truth be told, we've got a horrifically bad cable right now sending. Look at that. Look at that. You see that? Oh, Cisco is so amazing. I don't know if, hang on. I'm going to grab this, see if we can zoom in. See what's happening right there? Hang on. There we go. Fix my focus up a little bit. Is that easier to see? Can you see that? I'm trying to get the right angle. It's literally flashing that interface from amber to green. It's going flip, 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 flip. Now this is that. So there's a big difference. Enterprise grade switch, small business switch. This small business switch is like, oh, I'm just look at that. It's like, oh, I just lost connection. I'm just transmitting away. No worry. The enterprise grade switch is like, hey, you might want to look at this, and that should tell you something when you are so. Oh, it stopped, of course. But if you saw that, that was the interface errors and a visual indicator of the interface errors actually happening right there. So if you walk, think of the time that saves you. You walk into an IT room, and you're like, okay, slow performance. You're just looking at all the different, oh, look at that. It's like, that indicates errors are ticking up on that interface. So back to this. Collisions are something that should happen in the hub world. And what I was in the middle of saying when we kind of went on that little side tangent there, what I was in the middle of saying is that collisions should not, what was I saying? Well, it was something really important. Hang on. I said, da, 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 da. It was something really important. Okay, so I'll start talking. It'll come to me. So collisions should not happen in a switch environment. It's only something that happens in the old. Oh, that's what I was going to say. So I was waiting for it to hit me. So I was saying, even with this horrific cable, which is now blinking back to amber and green, it's so many packet errors, right, that are happening right now. We still don't see any collisions. I'll even hit the up arrow and refresh that. Collisions should not happen, even with the most horrifically bad cable causing all kinds of errors. Collisions only happen in the hub world when multiple people are sending at a time that shouldn't be. So if you're having a collision, or especially if you're having a late collision, what's the difference? Well, collisions and late collisions are the same exact thing. It's where two frames are transmitted and they collide because they're on a shared medium. A collision happens within the first 64. There's a certain amount. Hang on, let me look it up. All right, I'm back. 512. So, okay, if a collision's going to happen just because of the way the timings are all set up, it's going to happen normally in the first 512 bytes of a frame. So think of the old hub days. In the hub days, only one person could send at a time. And if two people would send, just the way that, and this gets into the CSMA CD, Carrier Sense Multiple Access Collision Detection Algorithm, because of the way the algorithm worked, I guarantee you every single time a collision would happen in the first 512 bytes of the frame. And that's what this records is anytime there's a collision, a normal collision, bing, that ticks up. Anytime there's a late collision, that means it happened after the first 512 bytes of the frame. either one of those things start ticking up, especially the late collisions, which never should happen, 99.999% sure you've got a duplex mismatch. All right, so I'm going to flip back to the slide because I think I covered all of these in my random rants and ravings. Runts, Giants, you got all those, right? CRC, it's where the formula is wrong, and that's where literally we see those happening all over the place. I need to like scribble this up. That's happening all over the place right here because essentially my cable's messing up all the data that's happening. The frame, that's an illegal format. I mentioned that. Collision, late collision, both of those indicate typically a duplex mismatch. And then input error is bad frames, at least all of these, into one single counter. Now, the reason I didn't include these in that counter is because the switch doesn't know it's a collision unless it transmitted it. Remember, it's like I sent that and I saw the explosion happen, the car accident happen on the wire. If it's on the receiving end of that, if it didn't send the data, then it's just like, man, just bad stuff just came to me, and it's going to record it as an input error. Does that make sense? So if you have one side of the connection, I'm just dumping stuff on you. So just jot it down, watch this video a couple times, right? Because it's just so there's a saying. I think I'm in a soapbox kind of mood right now. There's a saying, hang on, got the coffee. Knowledge can be transferred. Wisdom must be learned. And it's actually true. I can tell you all of this stuff and you can jot it down, but until you start going out there and creating your own bad Ethernet cable and start transmitting data and checking stuff out and watching it happen, it doesn't transfer from knowledge to wisdom. Knowledge is knowing the facts. Wisdom is knowing when those facts apply and what facts you should be using at any given point in time. So, cheers. You've now seen the interface counters to determine issues on switch port connections. I hope this has been informative for you, and I'd like to thank you for viewing.